Today, we're going to talk about a war, an invisible war that's happening inside of you, right now, every single second. It's the story of microscopic invaders and the incredible defense systems that are constantly fighting to keep you alive. So, let me ask you a question. Are you ever truly alone? I mean, really? Well, the answer is a hard no. Not even close. You see, you're actually a walking, talking ecosystem, a whole city of life. So who are all these roommates? Check this out. 100 trillion. That's the ballpark number of microorganisms living in and on your body. Now, for the longest time, the thinking was that they outnumbered our own cells 10 to 1. More recent science suggests it's probably closer to a 1-to-1 ratio, but still, just think about that for a second. For every single one of your human cells, there's a tiny little microbial tenant along for the ride, and most of them are totally fine, but some are just biding their time.
Okay, so to really get a handle on this whole invasion story, we first have to meet the locals. Let's talk about the permanent residents of our bodies, what's known as our normal flora.
This normal flora, you've probably also heard it called your microbiome, is this massive community of what scientists call commensals. The easiest way to think of them is like tenants in an apartment building, and that building is you, and they're great tenants. In exchange for a place to live, they don't just pay rent, they actively help out. They do things like make essential vitamins that we need, like vitamin K, but maybe the most important job they have is something called colonization resistance. It's kind of like they've already booked all the best rooms, so when a dangerous invader shows up, there's just no vacancy. The good guys are taking up all the space.
And this right here sets up the whole story, doesn't it? It's a classic tale of friend or foe. On one side, you have the commensals, our helpful tenants, and on the other, you have the pathogens. These are the invaders, the microbes that actually have what it takes to make us sick. And that's the central conflict we're going to dive into.
So here's our game plan. We've just met our body's hidden world. Next up, we're going to peek inside the pathogens playbook. Then we'll see how they cross our borders, what happens when the invasion kicks off, and finally, what those symptoms of war are really all about.
All right, so what is it that turns a regular microbe into a serious threat? What makes it a dangerous pathogen? Let's crack open their playbook and find out.
So when scientists measure a pathogen's threat level, there are two key ideas. First, there's pathogenicity. That's a simple yes or no question. Can this thing cause disease? But then there's virulence, and that's where it gets really interesting. That tells you how good it is at causing disease. It's the difference between a minor annoyance and a major problem. And just look at this example, it's wild. To get sick from Shigella, you might only need to encounter fewer than 100 of them. But for Salmonella, you'd need to ingest over 100,000. That means Shigella is way, way more virulent. It's just incredibly efficient at its nasty job.
So where does that high-level virulence come from? Well, it comes from a pathogen's arsenal, a toolkit of what we call virulence factors. I mean, seriously, think of it like an invading army's gear. They've got defensive shields, these capsules that help them hide from our immune system. They have grappling hooks, called pili, to latch onto our cells so they don't get flushed out. And, of course, they have weapons, enzymes to literally dissolve our tissues, and toxins, which are basically their chemical weapons.
Okay, so the pathogen is armed and dangerous. Now what? Well, every invasion has to start somewhere. For a microbe, that means it has to make the journey from its home base, its reservoir, into a new host. It's all about crossing the border.
This whole process is called the chain of transmission, and it is literally a chain. Every single one of these links has to be connected for an infection to spread. You need a source, a way out, a way to travel, a way in, and finally, someone who can get sick. And here's the key insight. Every single public health measure you've ever heard of, washing your hands, wearing a mask, cooking food properly, is designed to do one simple thing: break one of these links.
So where are these portals of entry? Well, they're pretty much exactly what you'd guess. The main doorways into your body are your respiratory tract, you breathe them in, or your gastrointestinal tract, you eat or drink them. And of course, they can get through your skin, usually through a cut, a scrape, or even an insect bite. Basically, anywhere your body meets the outside world is a potential entry point.
Let's make this real with a quick case study. Meet Burkholderia pseudomali. It causes a really serious disease called melioidosis, and its reservoir, its natural home, isn't another person or an animal. It literally just lives in the soil, specifically in the wet soil of rice paddies in places like Southeast Asia.
And this chart is just fantastic. It shows you exactly how the reservoir and transmission are linked. These are confirmed cases of melioidosis in Cambodia. And just look at that massive spike during the wet season, between May and October. So what's happening? Well, the heavy rains stir up that soil, kicking the bacteria into the air and water, which dramatically increases the chances of it getting into someone's lungs or a cut on their skin. It's a perfect example of how the environment itself can drive the chain of transmission.
All right, the border has been breached. The pathogen is inside the host. But getting in is only half the battle. Now the real invasion begins as it tries to get past the body's inner defenses. And once it's inside, a successful pathogen follows a pretty standard 4-step attack plan. First, adherence. It uses those grappling hooks, the pili, to latch on tight. Second, invasion. It starts pushing deeper into our tissues. Third, and this is absolutely critical, is evasion. It has to hide from our immune system patrols, maybe using its capsule like an invisibility cloak. And if it pulls all of that off, it moves on to step 4, damage. This is when it starts harming our cells and we start to feel sick. And a lot of that damage comes from those chemical weapons we mentioned earlier, toxins. And they basically come in 2 main types. You've got exotoxins, which are proteins the bacteria actively pump out, almost like little guided missiles that go after specific targets. Then you have endotoxins. These are actually part of the bacterium's cell wall. They get released when the bacteria dies and falls apart, and they tend to cause widespread general problems like fever and shock.
But you know what? Our body doesn't just sit there and take this abuse. No way. The moment an invader is detected, a powerful counterattack is launched. And the things we feel when we're sick, the fever, the pain, the swelling, those aren't the invader. That's our own body fighting back. Those are the symptoms of war.
This quote explains it perfectly. Those classic signs of infection are the signs of inflammation. That's your body deliberately opening up blood vessels to increase blood flow, letting immune cells and fluid flood the area to fight the invaders. It's the physical evidence of your body going to war.
And this whole battle plays out on a timeline that I think we all know intimately. It starts with the incubation period. The enemy is multiplying, but you feel fine. Then comes the prodrome. Ugh, that's that awful, vague feeling when you just know you're coming down with something. That leads to the specific illness period, when the characteristic symptoms hit you full force. And finally, if our defenses win, we get to the recovery period, and the sweet, sweet relief of feeling healthy again.
So, when you boil it all down, what's the big takeaway here? It's this. Infectious disease is not just about a germ being in the wrong place. It is a dynamic conflict, and the outcome is always determined by the balance of power between the pathogen's virulence, its weapons, and the strength of our own body's defenses.
And that leaves us with one final, pretty important question to chew on. This battle between us and them has been raging since life began, and it's constantly evolving. As microbes keep changing their tactics and our world keeps changing around them, what will the next great invasion look like?